In this video, we will continue with number 2 of the review problems. Uh, the last video left off on part 2e, where we found that the coefficient of friction is, according to the quantities that were given in this problem, 1.19, although an unrealistic number and an artifact of the numbers. And if you're curious as to how that works out, please see the last video. But in this video, we'll be wrapping up with parts F and G, where F says, if a 440 Newton force was applied in the negative x direction, what would be the acceleration of the block in the x direction? Okay, so there's an applied force of 440 newtons in the negative x direction. So now when we consider the sum of forces in the x direction, it's no longer just friction and the x component of gravity. This is part F. We have this force applied. We have, and that's in the negative direction, we have the force of gravity in the x direction. And there's friction, but now that the block is being pulled upward, the force of friction always opposes motion. And since this block is moving up, because of that applied force upward, up along the incline, then the force of friction is now opposing that, so it's going to be pointing down, which is the positive direction. We're going to just stick to using that mu from the previous part and just see where the numbers take us. All the steps will be correct. We're trying to find the acceleration in the x direction now that there's this applied force, and that applied force is 440 newtons. My x component of gravity, as discussed in that last problem, is going to be the force of gravity times the sine of 50. And my friction force is 1.19 times the normal force. And this comes from, actually I'll write out what the variables are. Mu times normal force is equal to m ax. And this is 440. Negative. So continuing to plug in numbers, plus the mass, which is 25, and 9.8 sine 50 is equal to, oh, not yet, plus coefficient of friction, 1.19, times the normal force. And the normal force we figured out in a previous part to be 157.5. And that's equal to mass, which is 25 times A. So now I'm just left with a lot of knowns, and the only thing I don't know is that A. So I'm going to see what my calculator tells me. I've jumped ahead just a few steps, and when I get to here, when I'm trying to find what this x component of gravity and this normal force is, what I should expect is that they're the same number, because that was the premise we operated under during the last part, is that this x component was equal to the force of friction. So depending on how you round it, and this is why I always say you want to keep as many digits as you feel comfortable. If I plug in these numbers, I don't get exactly the same thing, even though I know I should. So I'm actually going to leave it to 3 sig figs for now, even though I did get slightly different numbers, and I add those two together to get 347. I'm going to now subtract 440 from that. And I'm left with this negative 6d6 is equal to 25a. I could divide both sides by 25. And my acceleration is about 2.64. But really to the appropriate sig figs. And it makes sense why we want to round it, because we can't be so sure that this number is exactly accurate because we weren't given numbers that accurate to begin with. So 2.6, my final answer, as to the acceleration in the x direction now that there's this force being applied, and that's negative. This block is moving upward. And the second part of this part, F, acceleration in the y direction, it's still not moving in this direction along this dimension. So acceleration in the y direction is 0. Part G, if the block slides 1.5 meters up the incline, what will be its final velocity? This is assuming that the block starts from rest. So we have our acceleration, initial velocity 0, the amount of displacement is 1.5, and we want to know the final velocity. Okay, so which equation might help me out here? I know acceleration, I know all these things, and I want an equation that includes this so I can use what I know to figure out what I don't know. And the kinematic equation that's going to be most useful to us is v final squared equal v initial squared plus 2a delta x, where v final is what we're trying to solve for. It starts from rest. It has an acceleration of negative 2.6, and it's moved 1.5 meters in the negative direction. So this problem says it moves 1.5 meters up the incline. So its displacement is in the negative direction. Okay, we multiply those numbers out. And we get 7.8. The square of that is, the square root of that is actually going to be two numbers, positive, negative 2.8. And it's really up to us to decide, well, are we talking about a positive or a negative? Because this equation is such that it's squared here, we can't just tell by looking at the math whether it should be positive or negative. We have to use a little bit of logic. The block started from rest and it's accelerating in the negative direction, so it makes sense that it's going to have a negative velocity. Its position is changing towards the negative direction. Its position is getting more and more negative, so final velocity is negative.